All right, today we're going to, I think, reteach you how to write in scientific notation. I'm not sure if you guys have done this yet in your science class, but generally when you write very large numbers, we don't want to write all the zeros out. All right, so we try to write it in a short form notation. All right, so this is what I want to demonstrate today. All right, so I want everybody to take a look up here. All right, this number 1 is considered to be written in scientific notation because the decimal is after the first non-zero digit. So everybody take a look. See where the decimal is? Right? The decimal is after the first number. Is everybody with me? Now, to write it in standard form, that means to write it out with all of the commas. All right? So this is written in scientific notation, and it's always times 10. Now, the reason we say it's always times 10 is because that's what system we are using. All right? The decimal system. All right? In other words, everything's in powers of 10. All right? Everything's in powers of 10. All right. Now, in this case, we're going to write it in standard form. What I want everybody to do on the first exponent is that means to move the decimal 3 places. And then we say we move it 3 places to the right. 3 places to the right. All right? Anybody have any questions? Yes.
I have a question.
Yes.
I can't get my thing on notability. I keep tapping the thing that says "Oh, import link to notability" or something like that, and then it just goes away. Oh, here we go.
All right.
I got it.
It's coming up. All right. Thank you. So now, listen. So what we're going to do is we're going to move the decimal 3 places to the right. When I move the decimal 3 places to the right, here's how I like to start out. It's at 1.5. I moved it how many places so far? 1. Now I've got to move it 2, and I got to move it 3, and then the decimal goes there. So what do I need to add now? You have to add, call it?
Zeros.
You have to add zeros. Thank you very much. All right? So your answer to 1.5 times 10 to the third is simply 1,500. Everybody agree how easy that is, right? The exponent tells you how many places you need to move the decimal.
So you don't include the exponent in the final answer?
That's the answer.
Yeah, but you don't include it, the exponent.
Is that the answer?
Yes, sir.
So what is the answer to your question?
No.
Thank you. All right, remember we're going to learn to make some observations. All right, we're going to make some observations. That's how you get smarter. All right, now on number 2. All right, how many places am I going to move the decimal? Sebastian, I'm going to move the decimal 4 places. Now, I need everybody to look up, please. Look up, look up, look up. Because I think you guys are old enough this year to say I'm going to move it 4 places. Please pay attention. Look up on the board. I'm going to move it 2 spots. Do you agree?
Yeah.
So that means I have to add what?
2 zeros.
I just have to add 2 zeros. Or you can just look at it and say, since I'm moving it 4 places and there's 2 decimal places, I need to automatically add what?
2 zeros.
I automatically have to add 2 zeros. So my answer is 40100. So we say it's 40,100. All right, is everybody okay with that? All right, now let's take a look at question number 3. How many places do I have to move on here, Julian?
2.
So the answer is what?
6.78.
You didn't move the decimal.
Oh,
Leave them alone.
then you add 2 more.
Nope.
678.
Yeah, the answer is just 678. Because if I move the decimal twice, I'm trying to show you, if I move it once, move it twice, I don't have to add any zeros. So the answer was 678. 78. All right, Abby, tell me about 4. How many places do I have to move the decimal? So how many zeros do I need? Is everybody happy with that? Matt, you good back there? Oh, I'm trying to. I'm looking back there, and every once in a while, it seems like you guys are communicating. I just want you paying attention to me and asking me a question. And we'll be done here in a few minutes, and then you can kind of talk back and forth. Right now, you got to concentrate on me. All right? So it would be 5, 9, 2, 5 with how many zeros? Abby, what was it? 3 zeros. Now, Julian, one more time. The reason why we only have to add 3 instead of 6 is because this decimal has to be moved how many spots? 3 to get it to the end.
Oh, yes.
You with me? And now I moved it 3 to the end. I've got to add on another 3. So that would make that number, which again, I want you to make sure you put in your commas. So your number is 5,925,000. All right. Jesse, tell me about number 5.
Okay, number 5. So you would add seven zeros.
Wait a minute now. Look right here. So listen, this decimal right here, right? So if I move it over once, right, then I would have to add another what?
0.
No, yes, you're right. But how many more zeros do I need? Shh, I want her to think. Well, how many places do I have to move the decimal?
8.
8. So right now it's 7.0. So if I move it 8, I'm going to move it 1, and then I need how many more zeros? Let her answer. How many, Jesse? How many places was I supposed to move it?
8.
How many places have I moved it so far?
1.
So I need, 7 more zeros. That's correct. She needs 7 more zeros. So 1, 2, 3, 4, 5, 6, 7. And then I want to count out the zeros, 3, 3. So that looks like 700 million. 700 million. All right. Julian, you're up. Number 6. What do I have to do?
So you have the exponent 7, so you have to do 7 zeros.
Right.
You have to move the decimal place, so it's going to be.
How many zeros do I have to add?
You have to add 7 zeros.
No. How many places do I have to move right here? Tell me. 7, right?
7, yeah.
So if I move it 7,
Yeah,
I've moved it how many so far? So how many more?
you need 5 more.
So I need to add what?
5 zeros.
5 zeros. So 9, 9, 9 with 5 zeros. 1, 2, 3, 4, 5. Then there you have it. All right? You good with that? Try the next one. All right? Yeah. We're going to get to that. Very good. Okay. So now, number 7. Go ahead. Tell me what to do on this one. You can do it.
For 7, you have to move the decimal 5 places.
Exactly.
So you just add that.
You just need 1 0, right? Because from here you moved it 1, 2, 3, 4. Does that make sense? All right. So your number should be 3 0 0 0 5 0. So your number is just 300,050. All right. Will, you're on number 8. What do I need on number 8?
Number 8, so you just have 3 zeros.
Yes, you add 3 zeros.
250.
Very good work. 254,000. I'm happy. All right. So Miss Bragdon, number 9. Help me out with that one. Because you have to add how many zeros? Very nice work, girl. 17500. 17,500. Now, Ellis, you got the one. I want to see if you're thinking. We have a problem here, right? Because we have a negative exponent. Which direction do you think we have to move? That's right. So you need to make sure you make a note to yourself. Negative exponents means you have to move to the left, which means it's a very small number. Very small. So now, how many zeros do I have to add? You have to add 5 zeros. So it would be 1, 2, 3, 4, 5, 1, 2. Everybody happy with that? Now remember, I'm trying to tell you, you should write the answer and then look what I got and compare. Anybody have any issues? Connor, you want to try 11?
Sure.
All right, let's give that a shot. Everybody take a look at number 11. Try to do, everybody try, oh, this one's an easy one though. What do I have to do?
Just move one spot forward.
So the answer is just what? Very nice, 0.7. That wasn't bad. 0.7. Did everybody see that? We're just moving it to the left one. So we didn't have to add any zeros, is what he's saying. All right, number 12, Colin. What am I doing on that?
Okay, so you're moving the decimal 3 times to the left.
Yes, sir. So
So
what's my answer?
the answer is 0.0063.
Very nice work. Very nice. Easy. Now remember, your job right now is to see if you understand what I'm talking about. Julian, good back there?
Mhm.
Julian here? Girls?
Yeah, they have a brother.
All right, here we go. Caroline, 13.
They're going to do 5.83, and then they're going to move 2, they're going to move 2 to the left, and it's going to be equals 0.0.
Good job. She knew it. 0.0583. Perfect. 0.0583. Everybody happy with that? All right. Now, who hasn't said something so far?
5.
Sebastian, what do I got on 14?
So it's 0.0008075.
Yeah, guys, I told you this is very easy. It's very easy. All right, anybody have a question on this? Writing in scientific notation. Sometimes you're going to measure things that are going to be really small or they're going to be really large. So you can't always write things out. All right? Now, here's what I mean by that. So let's take a look at number 15. Now we have to write it in scientific notation. Now here, sometimes it's a little bit more difficult for kids. But I want you to remember, the decimal goes after the first non-zero number. So in 1 million, where would the decimal go? Tell me.
I just put it up.
After 1. All right? Now, what I would like for you to do is, I would like for you to go ahead and write 1.0.
Just that.
1.0, and then tell me it would be times 10 to the what?
Times 10.
Yes, times 10 to the 6th. Now, how we got that real quick was the decimal here. I moved it over 3 6 spots. All right? Madeline, you okay?
Yeah, I just.
All right, I'll let you do 16. Write the answer to 16, please.
Okay, so it'd be 1.74.
Exactly, 1.74. Now, could if I wanted to write 1.7400?
Yeah.
Yeah, but we don't want to write the zeros in there because that doesn't change anything. So 1.74 times 10 to the what? Times 10 to the 4th. Remember, always know that the decimal is after the first digit. And then how many places did we move it? We moved it 4, so that corresponds to the exponent. That corresponds to the exponent. All right? Everybody happy? All right, let's take a look now at question 17. Avery, go. Yes, I want you to say that. 5.0 times. Yes, perfect. 5.0 times 10 to the second. You guys agree with me? Simple, right? All right, Ellis, you help me with 18, please. Uh-huh. So that would be what? Good job. To the, what do you think? Yay, good job. Julian, okay, come on. You're up.
Alright,
Now look,
so-
I'm not sure. Look at 15, 16, 17, 18. All right, now I want you to go to 19. Is 19 a big or a small number?
smaller.
So the exponent is going to be positive or negative.
Negative.
Right. So where does the decimal go? After what number? After what number? It's got to be a non-zero.
So 2.
Yes, exactly. Come on now, that's called thinking. Notice you didn't, mumble, you didn't do any of that other stuff. You just thought for a second, and I said after the first non-zero digit, and the first non-zero digit is 2. So he is correct. The number would be 2.7 times 10. Now, come on, I'm putting the decimal here where you told me to put it. Now, how many places did you move it from where it was?
I moved it 3 or 4.
So here it is. 1, 2, 3. Beautiful. 4. Now, is it 4 or negative 4?
Positive.
Somebody help him
All negatives since we're moving.
because it's a small number. Negative for small, positive for big. Is everybody good on this? So it would be 2.7 times 10 to the negative 4. Beautiful. All right, Abby, you think you're good?
Yeah.
All right, 20. You tell me 20 real quick.
5.
Yep, I told you guys. Simple, simple. All right, anybody in the back hasn't given Max Behane, you're up 21.
Number 21. 18 times.
Would be what?
Oh.
Come on, sit up now, buddy. Come on.
1.8
Yeah, there you go.
times 10 to the 1.
Yes, very nice work. You hear me now, right?
Yes.
Now remember, you guys, the point is if you're not sure, just raise your hand. Let me help you. All right? If you're good, then just continue on. All right, Jesse, you want to help me out with 22, please? What are you thinking, kiddo?
Okay, so first you would put it like we put
Say it. Go ahead. You're right.
1 point.
Yep. Yay, girl. I told you. 1.25. Then you automatically put times 10.
And then that would be to the negative 1 power.
Yeah, right? Negative 1, right? Because you just moved it what? One spot. Easy, right? Very, very easy. All right, Miss Bragdon, you're up again. Let's hear you. 23, girl. Wait a minute. Not 17. Let her make her own correction. It goes after the first digit. The decimal goes after the first digit. What's the first digit? Yeah, there you go. You hear me now, right? 1.7. All right, 1.7 times 10 to how many places? You're awesome, girl. Perfect. 1.7 times 10 to the 10th. All right, Julian up front, 24. Well, actually, I don't want you to do that one. Vivian, do 24. What would that be?
1 times 10 to the
10 to the what?
negative.
Good job. 10 to the negative 2. All right, again, I always remember negative means small. Negative means small. Is everybody good with that? All right, so here we go. Let's check out. All right, Julian. All right. Tell me about 25. You.
Alright, so, it's a bigger number, 2 move to the right,
Okay.
and you move to 8.
Just what I want you to do is where does the decimal go? Let's start with that.
The decimal goes
After what?
after,
After the 2. It's after the first digit. So what number am I going to write down?
2,
2. Then what?
and then time,
No. What number's left? Come on.
1,
And?
and, 8, because 8's
So 2.18. All right. Now, what's after 2.18?
Zeros.
We're trying to write it in scientific notation.
So you would write
2.18. Stop doing that. Look up and see what comes next after every single thing.
times
Times what?
times 0
Times what? Shh, don't tell him. Times what?
10
Why is it times 10?
oh,
Because every single other one has always been what?
times 10.
That's the pattern. Everything is times 10. Now the question is, the exponent. How many places did you move it?
You moved it 2.
It was right here. The decimal goes to the end.
So yeah, and it went to the 8. So
It didn't go to the 8. It goes to the very end. How many places did you go from here to here?
that's 4.
Yes, 4. Put that down. Come on, you're doing the next. All right, 26. What? Yes, you.
All right. So since you have your
No, just stop. Just tell me, where does the decimal go?
the decimal goes right.
So, now what?
So then what you want to do is you want to do 4 and 5. So
Right, okay. 4 and 5.
And then you want to multiply by 10.
And then tell me, come on.
And then and then you move the decimal.
How many places to the end?
7.
Well, it was here, right?
Yeah.
So how much is this?
Oh, 4 or 3.
And then how much is this?
And then that's another 3.
So,
So that's 6.
yes. All right, next one. Same one, Julian.
27. So it's smaller numbers, so you're gonna.
Just tell me how to do it. Just tell me what the answer is.
All right. Okay.
Gotcha.
So you have the 4 and
So where would the decimal go?
so the decimal has to go to the next one, so it's gonna go to the 5.
So what number should I write down?
So you're gonna write down 5,
And then what?
and then put 4,
Good,
and then that times,
good.
and then it took 2 places to move. So
Did it
you're gonna
really?
write times
Here it is. Here it is.
and then 2.
How many places did it move? Here's where it was.
Oh, 3.
Okay, so it'd be to what power now?
Third power.
Close.
Oh, negative third power because it's a negative.
Because it's a
It's
decimal.
smaller.
Yes, it's small. All right, 28. Let me have the other Julian this time.
Oh, 28.
Yeah.
9.9 times 10 fifths.
No. What'd you forget?
Oh, negative 10.
Right, come on now. It's a decimal, it's a negative exponent. All right, is everybody good with that? All right, now let's look at important problems. Now, they're trying to confuse you here. Look up, guys. Please look up. The most important thing is the exponent. That's what determines how big something is. If you have a cube and you have a -4, which one's bigger? The cube is bigger, right? So the greatest number is, and let's just circle it. This is the greatest number. Does everybody agree with that? They try to trick you because what? 8.8, 9.1, which one's bigger?
9.1.
Everybody see that, right? But the exponent is what determines how big something is. All right, so let's look at 30. Caroline, which one's bigger? The first one or the second one? The first one is definitely bigger. Good job. Connor, which one's bigger?
It's 10 to the 3rd power.
That's right. Because this is, if I wanted to, I could write that as 9.0 times 10 to the what? Second. Do you agree with that? I like what you said. To the 3rd power is bigger. All right. Now I think we should write it in scientific notation. So how do I write scientific notation for 0.02?
Oh,
Go ahead.
is it 0.02? No.
It goes after the first non-zero.
Oh.
So it's let him try, let him struggle. It's good. It makes you smarter when you struggle. So what is it? Remember, look at every example problem. The decimal goes after the number. So what's the only number up there that counts? 2. So it goes after the 2. 2.0. 10 to the what? Right, there you go. So now which one's bigger? 1.9 or 2.0? Right, because they have the same exponent, all we have to do is look at the number now. Do you agree? Is everybody happy with that?
Yes, sir.
All right, here we go. Well, 33 is kind of easy. What are you thinking, Jesse?
Second one.
Second one is bigger, yep, because the exponent is bigger. Very good. And 34. Now, 8.39 would be what? How do I write that? 8.39 times 10 to the second. So now you're just comparing 8.4 to 8.39. Which one's bigger, Abe? Be careful, they're trying to trick you. Yes, 8.4 is bigger. Is everybody okay with that now, guys? All right. Now we're going to order each number from least to greatest. Okay, so let's just put 1, 2, 3, 4. Is everybody happy with that? So which one would be the smallest? Who can do this? Which one would be the smallest? Sebastian? So let's put a 1 right underneath that. Because it has -3, right? Then the next one would be what, Sebastian? Nice work, Sebastian. What's next? I'm happy with you. And finally? Is everybody good with that? Everybody good? Now the next one's hard because there's some of each, so we're going to convert them all. All right, I want you to convert them to a scientific notation. So what's the first one as scientific? Yes, nice work, girl. And then? Very nice work. Very good. All right, so now let's write 1, 2, and 3. Which one is the smallest?
The smallest one would be 6.4 times 10 to the 5th.
Good, so let's put a 1 there. And then what?
6.4 to the 6th.
Good job. Then what?
Then 6.4 times to the 7th power.
Yeah, girl. Nice job. Pat yourself in the back. Good job. Now, listen, guys. Is that good? You good? Good? Good in the back?
Yeah.
Julian? I know. You can come sit up close to me. All right, I'm going to help you. All right? So, again, now your job is just to finish up that worksheet. Is everybody happy with that? Everybody good? You got to do the second worksheet now. All right? Get busy. Try to have no homework. Remember, would be a nice thing. All right?